you are doing well. I hope you guys are enjoying the college right now. So yeah, first of all, I'm Anirudh V. Gubbi. I'm a second year CSC student. So I'm app developer at the Iris team. So for some of you who don't know Iris, like I hope that until now everyone would have used the Iris, at least the web. So if you're not familiar with the app, also we have an app. It's called the NITK Iris app. Right now, it's only available on Play Store. It will be soon on iOS also. So if you haven't yet installed, you can search it out and install. It's a very convenient app. So now, moving on to the first session. So for the first session, we'll be covering the fundamentals of Dart and Flutter. So let's just begin right away. And like, if you guys have any doubt, or if you feel that I'm going a bit slow or a bit too fast, and if you're not understanding some things, you can just stop me. You can like interrupt me at any time, or you can just put your doubts in the chat. So we won't mind. So you guys can see my screen. Guys, please interact.
Yes.
Yeah. Okay. Good. So let's begin. So first, So just keep on explaining about what's Dart and Flutter, and also I'll go through a practical application, of each programs in Dart and Flutter and how to use them. So now, first, let's speak about Dart, right? So now, what is Dart? So I hope that a lot of you are familiar with what are known as programming languages. So where you write some instructions that the computer can understand, and it executes them and produces some outputs that you require. Now, what is Dart, right? So now, Dart is also one of these programming languages. But the thing is, it's a high-level language, and it's also an object-oriented programming language. For some of you who don't know, what's a high-level language? High-level language means that you don't have to deal with the very basics of computer architectures and all. Like you don't have to worry about the memory used by the program or anything, and also the syntax in which you'll be writing the program will be more or less like English. So it is much beginner user friendly, so you can you can basically master the language very fast. And the second thing about that is it is an object oriented programming language. Now, what's object oriented programming language? Like, so in object oriented programming, you model your code, as an object which has its attributes and features and some functionalities. So you basically bind these together into a class. So you make instances of these classes. So these instances are known as objects. So if you have one class, you can have as many as objects you want from these class, and in each object it will have its own features and its own functionalities. So these features, what I call, are known as class variables, and these functionalities are known as member functions. Okay, so if you are not so sure still, you can still watch some playlist that we're gonna recommend, or right now I'm gonna teach you how to implement oops in that. So you can, so you can just chill right now. Now, what makes Dart so special, right? So we have other high-level programming languages which are easier. We have Java, we have C Sharp, we have C++, so many things. But what makes Dart so significant is that, first of all, it is optimized for applications, for web applications, for making apps, and so on. So, and these apps are also cross-platform. So you don't have to, write some code for Android, and then if you want to deploy the same app in iOS, you would have to write the code again for iOS. So you don't have to do this stuff. So if you write a very good code in that, you can basically run the same app on Android, on iOS, or anything. So that's cross-platform. Now, the second feature of Dart is that syntax of Dart is very much similar to Java, C++, or C Sharp. So these languages which were based on C. So if you know Java, some of you might be from ICSE syllabus, or some of you may be from state or CBSE. So I'm sure that you would have at least learned Java, C++, or Python. So if you know Java or C++, I would say that like you know almost 60 to 70% of Dart. So you can like just learn uh, some of the extra concepts, and you can uh, master this language, right? And the last feature that I would like to say is that it's a type safe language, right? So if you are declaring a variable as an integer, like you can't assign it to a string, or you can't assign it to like other types of variables. So that's known as type safety. Now, one very special feature of Dart is that it has what is known as null safety also, which I will show you again through the example of a program. So let's to talk about that later. And now, why we are learning that is that Dart is the language which we will be using to write apps using the Flutter framework. So Flutter framework, which were Flutter and Dart, both were developed by Google. So to write apps in the Flutter framework, we are going to use a Dart language. So right now, let's just hop into a Dart program and see what's the syntax and how it works. So right now, until now, does anyone have any doubts, or if you have any problem with this, you can speak up, or I'll just move to programs. Okay. So I guess you guys are fine with the speed. So I'll just continue on. Now, first, let's open a file. Okay. So now, programs in Dart, they usually end with the extension .dart. So you can see session1 .dart. So this is the extension. Now, if you're familiar with some of the languages, we'll just write a basic a main function now. So the same as Java or C++. So this is our main function. So first, okay, I'll just explain what's happening in this thing. So first is void. Now, a void is a data type. So like you have other data types in that, like void, int, string, and so many other. And the next is the main, which is the name of the function that I want to execute right now. So in that, and like any other programming languages, the program starts through the main function. So inside the function, let's just write our basic thing. Let's write a hello world program, right? Yeah. So now for printing onto the console, the console is right over here. So to print over here, you can just use the function called print. So for the print, I'm specifying a string over here, and the string is hello world. So if I run this program, I'll be able to see the string hello world on the console, right? So this is our first program basically. Now, let us say that this is way too much basic, right? So let's go a bit more advanced. Now, so if you want to write a comment in that, you can just start with double slashes. So this will be a comment. So this piece of code won't be executed by the compiler. This is just for our reference. So you can also write the comments in the star and /1. Okay. So now first, let's try to declare variables in Dart. Okay. So now, like I said, we have a lot of data types in Dart. So first, let's go with basics like int. So when I declare int, so int a equals 5. So here, this is the data type. This is the name of the variable, and here I'm assigning the value 5 to int. Okay. So now, just like in, we also have double, which we can give it as 3.5 or 3.6. So if you want to, not only store integers, but also with some decimal points, we can use a double for that. Now, one of the most famous data type is string. So if you want to have a string, you can have it as like this. So a string, it can have spaces, it can have special characters and all. So this is a string. And one more thing about Dart is you can also declare strings inside single quotes. Okay. So this is a string too. Now let us say that like you don't know, or like the name of the data type is too long, so you don't want to write the data type completely. So if I don't want to write string every time, Dart has another functionality called as automatic type inference. So I can just write the keyword var. So here var stands for a variable. So we just write var str equals this. So it is going to automatically infer its type as string. So if we just like hover over this, you can see that it's saying string str3 because I assigned it to a string. So if I let's say I assign it to just 4, then it's going to say int str3. Okay, so that's a very cool feature of Dart. And just like where you have another keyword called dynamic. Uh, Dynamic also supports like any other functionalities. I can have it as a string. So if you just hover overhead, it says still dynamic. Now that's because dynamic variables can change that data types like at any time. So if I right now h equals 4 or 5, like it's still fine. Yeah, so it's still fine. But over here for var, if I try to change its type from int to now, let's say a string. Okay, wait. Yeah. So var, we can change the uh, data type from like whatever we want. So now right now string will be okay. That's weird. Okay. Yeah. Let's just forget about this. Okay. So this is the dynamic type. Now, like I said, I was saying something about null safety, right? So let's talk about those. Now, if you just write int, let's say I make a new scope, I'll just say int a. Now, if I just write int a, this is actually not allowed. And the reason this is not allowed is because, yeah, so the reason I can't have int a is because here right now I've not initialized anything to a, right? So that is going to throw a syntax error. But let's say that I want a to not have anything because like if a has something, I can use that data. But if a does not have anything, I can just say that okay, let's not work with this variable right now. So here that nothingness in that is represented through a keyword known as null. Right. Okay. So now what if we see we can't assign the type null to a, and the reason it is saying that the type null can't be assigned to the type int. So the thing is here by default in that like every data type that we are going to declare will be non-nullable in nature. Okay. So that means that we can't assign it to null. So we need to assign it to something else and then use it. So, but if I want to use the type null, what I'm going to do is I'm going to uh, add a question mark in front of in front of int. So now if you see it's all right, and the value of null can be stored in a. So these types, that start with a regular data type and then end with a question mark are known as nullable variables in Dart. Okay, so you can perform checks. So you can say if str equals null, then do something else, or if str is not equal to null, then you can actually work on the flow of the program. Now let's look at some other operations on nullable variables. Now Okay, so let us say I have an integer a. Okay, b equals 7 now. Now, let us say that I assign a to an actual integer now. So first it was null. Now, assigning it to the value 10. Now, I want to store this value that I stored in a in b. But the thing is, again, sometimes this won't work. And the thing is, because b is a strictly non-nullable type, and a can be sometimes null or it may not be null. So, like, we may not necessarily know. So if you just hover over it, it says that a value of type int a question mark, which means a type of nullable int can't be assigned to the variable of type int. So here b is int and a is nullable. So what we use is it's called a bang operator, which is just a exclamation mark. So what this does is here this exclamation mark is basically saying that the value of a that I'm giving will necessarily be non-null. So it is basically a confirmation saying that you can safely assign the value of a to b because I know that a is not null. So this is not a bang operate. Now let us say that a like a might be null. So like in that case, I want to assign b to a let's say 5 or something else. So in that I'm going to use a double question mark operator. So here what it is doing is it says that first let's check the value of a. So if a is not null, yeah, like then we are done. We are basically just doing this, right? So we are just assigning it to a. But now in case that a is null, then we are not going to use the value of a, but instead we're going to assign 5 to b. Okay. So I hope everyone is understanding it. And then the last operator is a single question mark. So let us say I have a nullable type of double. So now num has these functionalities. So I can just say find the ceiling of it. Ceiling is like ceiling of 5.5 would be 6. Ceiling of 7.9 would be 8. So like that. So now if I had it as null initially, now you can see that I can't call the ceiling function from num, and the reason is you can see the method ceil can't be unconditionally invoked because a receiver can be null. So we can't call the ceiling on this num because here num can be null. So because the ceiling of null, like we can't figure that out, right? So that's why what we use is we use a question mark operator before the dot. So here what it is saying is if num is a not so the value of num is not null, then you can safely do this. You can just call num dot ceil and you will have the answer. But in the chance that num is actually null, so then this function won't be called, and instead the value null will be returned. So if I was storing this value somewhere, was storing, let's say in num2 equals this. Yeah. Yeah, so if I was trying to store the value, okay, so ceiling returns an int. So if I was trying to store it in over here, now since here num is actually null, so this function won't be called and the value of num2 will be set to null. Okay, so I would say like this is all about null safety in Dart. So if you have any doubts, guys, like if you want me to repeat anything again, I'm happy to do that. Anyone has any doubts?
Can you repeat the double question mark thing again?
Yeah, sure. Okay. So we're here now. Yeah. So now we want to like assign the value of a, right? So a is an integer and b is also an integer. So now I want to store the value that is stored in a into b. But right now b cannot be null, right? So it is a non nullable data type, whereas a is null. So in the cases where a is null, b will be will also be assigned to null, which is not allowed, right? If I just do this, it's gonna throw an error. But what I can do is I can instead say that if the value stored in A is right now null, so what you do is you don't try to store the value of A in B now. So just skip all this. So you can skip from here till here, and you can just say B equals 5. So here 5 is basically the default value, right? So I'm just saying that if A is null, then only you assign B to 5. But in case A is not null, then you can just safely assign A to B. So if let's say here, if I had A equals 10, then if I do this, then the final result will be B will be equal to 10 because A was 10. But if I don't do this, so A will still be null, then in that case, B will be set to 5. You understood it?
Yes, yes.
Okay. Uh, Anyone have any doubts? Okay, so I guess no, I hope everything is clear over here. So let's move on to next concept in Dart. And yeah, so now until here I was just talking about variables, right? So things that will keep on changing. But let's say that I want to declare something which I know that will be constant during the throughout the whole execution of the whole program. So these words are known as constants. So I guess so I'm sure that like some of you would have heard about constants in some of the languages. So let's see how they work. Now in Dart we have basically three types of ways. Okay, we have two ways of having constants. First is using the keyword const, and then next is using the keyword final. So first, let's see const. So as like you would have already guessed. So when I say a variable is const, it means that I can assign a value to it, right? So I can just say k apple equals apple, but after this, I can't change the value of k apple to, let's say, a banana. So I can't do that. Why? Because k apple is a constant. So its value throughout the execution of the whole program has to be the same. So if you hover over, it says constant variables can't be assigned to like another value. So you can't do this, right? So when if you try to assign it to the same value also, it will still throw an error because you can't change the value of k apple like after initializing it once. So you cannot do this. So these are constants. So if you want to have like any other const, you can have const pi, right? So pi equals 3.14. So here, as you can see, I did not have to specify the type of pi as double. So if you're declaring some things with const or final, you can just like not have to provide the data type, because since it will be assigned only once, so the type of the right hand side will be inferred to the left hand side. So if we just hover, it says pi is now a double because 3.14 was double. So now let's move on to the next keyword, that is final. So final, I'll do the same thing. I'll say final, let's say k banana now. So I'll set it to banana. Now, if I try to change the value of banana to something else, again, I get the same error that the final variables also can be only set once. So I can just do this, I cannot do this. But now, like you can see that const and final have the same functionality, right? So like, why do you require final as another? We could have just been happy with const. So the thing about finals is that you can actually first just declare them, so I'll just say k pair. I just declare. Okay, so like here I'm not assigning it, but after some time, so after some time I do some execution of the program or something, and then I'll say that k pair will be equal to the string pair. So as you can see, I don't always have to specify the value of pair over here only. So we're going to do it after some time. But again, we cannot do it again. So we can't say we can't reassign the value of final variables again, because the same error shows up that the value of finals can only be set once. Now, on the other hand, if you try to do the same thing with const, right? So if you say const a and then a equals 5. This is not allowed because the values of constants have to be initialized when you're declaring them itself. So the final variable, final variable gives us basically this flexibility to have the data type first, and then when we have some data, we can store the data into final variables, and then we don't have to touch the variables again. So like after we set them, they will basically behave as constants itself. Okay. So these was all about variables and constants. Now let's move on to something which is very important in every programming language. That is conditional operators. Okay. So in that you have like a lot of conditional operators. I'll just talk about very basic ones. So let's say I have a nullable integer a. Now I want to check, right? Okay, so let's just say I have a equals 5. Yeah, so I have a equals 5. Now I want to see if a is odd or even. So what I'll do is I'll use the statement if. So if, and in the brackets I'll say the condition. If a mod 2, right? So here the modulus operator, I'm sure you would have learned it in mathematics. So modulus operator will basically give you the remainder after you divide a by 2. So here now if a mod 2 is equal to 0, then that means that, so here this was the condition that I said, and now if this condition is satisfied, then the program will go on to execute this body which is contained which is filled in this two curly brackets. So here I will say that print, I'll say a is even. Right. Now here, this may not always be true. So right now it is a is 5. So a mod is actually 1, right? So what I can do is I can write like another if condition, but here I'm going to use the condition else. So else basically says that if the first condition is not true, then we're going to check if a mod 2 equals 1. So which means that a is even. Sorry, a is odd. So we'll do the same thing. We're going to write print. We'll say a is odd. Okay. So you can keep on doing the same thing. You can write like another else if, another else if. So you can have as many else and ifs as you want. Now let us say that a was not initially initialized. So and since a is like a nullable variable, a can be null, right? So here you can see that this will again throw an error saying that the operator mod can be unconditionally invoked on this a because a can be null. So here what we can do is we can first add like another check now. So what we'll say is first we'll check if A is null. Then we'll say A is null. Now if A is not null, then we can do like the regular execution of the flow as we want. So this is how you use if else ifs. And let us say that you knew that the value of A will like never be null. So what you can do is you can use the bang operator over here. So you can just use bang and say that a like I can say that a is not null. So you can safely so you can safely call the mod operator and do this. So this is all about if and else. Now uh, so now let us talk about looping statements. Loops. Now loops, in that we have again for loop, you have a while loop, you have a do while loop. Yeah, so there are so many loops. So let's just learn right now. Let's just learn for while and for loop. So these are very basic. So let us say I have a variable called counter with counter being 0, and I want to go until the maximum value. So let us say 10. So now like what I'll use is I'll use the keyword while. So while, and again in the brackets I'll say a condition. So I'll say while counter is less than max, and then I'll start the body of the loop. I'll say print counter, and then I'll say counter plus plus. So a counter plus plus will basically increase the value of counter by 1. So here what we're doing is we are first checking if counter is less than max, then we print it, then we increment the value of counter, right? So now after this, again we check the condition and we print it and increase it again. So here this will go on until counter is 10. After that, counter is won't be less than max, it will be equal to max. So this body won't be executed, and then the flow will come over here. Okay. So this is how you write loops. Now we have another loop called a for loop. So for loop, let us say I had not initialized the variable counter here. So what I can do is I can use the same syntax. I'll just say int counter. It's starting from 0, and then I'll put semicolon. After semicolon, we need to specify the loop condition. So our loop condition was counter being less than max. And after this we will have to provide another semicolon, and then the last will be the either increment operations or decrement operations. So basically, like everything that will be executed after this body has been executed. So here I'll say counter plus plus, so which will increase the counter. Now because of that, I don't have to do this inside the body. So over here, the exact same things will happen. First, this statement will be executed. Then we'll check if counter is less than max. We'll print the value of counter. Then we go to counter plus plus, and then again back to condition body. Then the increment operation. So here we will be printing a counter from 0 to 9. So this is all about loops. Now after this, I'm going to start about functions. So if like anyone has any doubts until now, yeah, you're free to ask if you have any doubts, or you can put them in the chat. Okay, so no specific doubts. Okay, good. So let's move on. Now until here, it was the very basics of Dart. So let's move on to a bit more advanced and write functions. Now, in any programming language, what's a function? A function is basically a set of data that you're going to be, that you can, set of instructions that you can, use again and again, so that like you don't have to write the same code in your code again. So you can just write those specific instructions inside a function, and then from anywhere you want, you can just call that function and you can have the same functionality. So how do you write functions in Dart? So again, so here we had written the function main, right? So main itself is a function. So you can have any other function. So now let us say we were printing all the numbers from 0 to 10, right? So let's write a function for that. So let's say it is again a void, because from this function we won't be returning anything. So let's just say void. Let's call the function print integers. So the name can be like any a combination you want. Now here inside the brackets, now here we had a max variable, right? So let's say that for each time I call this, I can have a different value of max, so 5, 10, 15, whatever. So that's why I'll have this max as a function parameter over here. And after this, like anything else, I'll start the body of this function. Okay, so now I'll just take this whole thing and copy paste it over here. So as you can see, I'm doing the same thing. I'm doing for counter from 0 until max, which will be provided to the parameter. I'm going to print the values of counter from 0 to max minus 1. Now from this, what I can do is I can just call the function. So how to call a function? You just write the name of the function, and then here we need to provide a parameter for max, right? So let's say I'll call 10, and that's all. So this whole function will be written for max equals 10. Now let us say that I want something else. I want to print until 100. So you can just say again 100. So here, as you can see, I do not have to write this loop again, for counter equals 0, counter less than 100. So you can just say print integers of 100, and here for this time max will be set as 100. So I'm basically using the same set of code for different parameters basically. Now let us write a square function, right? So if I provide it an integer, it should return the square of that integer. How would we do that? Now a square of an integer would be again an integer, so we need to return this value from this function, right? So here the return type of the function would be an int. So I would say int and then square, and square will again take an integer I. And then here now uh, uh, let us first store the value, right? So let us say square will be equal to I into I. So here I into I is basically I square. So I'm storing the value of I square into the integer variable square. Now I need to send this value of square back to the function we were calling it, right? So if I was calling it from here, let's say int square of I. Now it should be called from the square function, and let's say square of 5. Now here this function has to return the value of 5 square back, right? So how do we do that? Now we are simply going to write the word return. So I'll write return and then sq. So here the function is basically going to return the value of sq here that we calculated as I square, and then it is going to set the value of square I through this function. Okay, so this is how the function calls. Now here you can make a bit more. You can write fewer lines of code over here. So how would we do that? Like we don't need to store the variable, right? So we're just finding the value and then returning it back to the function. So what we can write is we can just say return I into I. So here the value of I into I will be calculated, and then it will be returned back to square I. So here we don't have to store the value first. Now we can do a bit more. The thing is we are just calculating something and then returning it immediately, right? So we're not doing any other things over here. So what we can how we can shorten this a bit more is, instead of opening the body, we use a fat arrow operator. So when you write fat arrow operator, you can just say I into I. Okay, and you can put the semicolon. So here, as you can see, we don't have to use the braces, or we don't have to use the keyword return. So here, when it comes here, it just sees that, okay, so if I have a value of I just need to calculate I into I, and then I need to return the value of I into I back to square I. That's all. So from 4 to 5 lines, I just reduce it to a single line function. Okay, so that's great. Now, okay, so let's come back to print integers function. So now let us say that I don't want to always start from minimum, sorry, 0. So I want to start from a set minimum. Okay. So what I'll do is I'll pass in another parameter here, which will be called as min. So I'll say that the value of counter now will have to start from min. So I can say it can start from 0 until 10, or I can say that it can go from 65 until 10, or anything like that. So we have made this function a bit more flexible. Now, okay, so now the function was here, so you could say that we had to provide min first and then max, so provide 0 and 10. But let us say that this function was, there in some other files, so did not know. So in that case, what helps you is uh, what are known as named parameters in Dart. So this is a very cool feature in Dart. So what you can do is you can basically say the names to these parameters, right? So how do you do that? So in the parameter list, you just start it with a pair of curly braces. So in this, you write a parameter. So you write int min, and then you write int max. Okay, so right now it's showing an error. So so let's just like ignore that. I'll explain that later. You can just say int min and then int max. And now over here, how do we call the function? How do we call the function? Is we say print integers. Now first is the min, right? So here I can say min will be 0, and then max can be 100. So here this is going to reduce the ambiguity of the code a lot, right? So we can say that the value of min has to be 0 and max has to be 100. So you can also change the order of the parameters also. I can just say first max should be 100 and then min should be 0. So here these two will have the same functionality, that the value of min will be set to 0 and max will be set to 100. So these are known as named parameters. Now, yeah, as you can see here, it was saying this was making this was having a syntax error, right? So the thing is, when you have these parameters inside curly braces, the thing is you don't necessarily have to pass the parameters, right? So you can just call the function. So in this case, you would be like assigning a value of null to min and max, so that function would work. But here, since we had said that int is not of an nullable type, it is going to throw a syntax error saying that the parameter min cannot be null. So here, one workaround is we can just say we can make these variables nullable, and then over we can use the bang operator saying that I'm sure that these won't be null, and then you can do the same thing. So again, set max to be 100 and then min to be 0. So this is going to work. But here, like, the thing is, I know that these things won't be null, right? So if I have to run this function, I will have to require min and max. So if like any one of them is null, I won't be executing this function anyway, right? So here, like, what I want is I want int to be non-nullable itself, right? So I don't want to do these all these extra things over here. So here, what I'll use is I'll use a keyword called required. Okay, so a required int min and required int max. So when I do this, what happens is, so it's basically saying that this function will have to require the parameter min and will have to require the parameter max. So if I try to do the first thing that I did, of not sending any parameters, now the syntax error, like, it won't be in the function, but it will be at the instance when I'm calling the function. So it is say that the name parameter min is required, but we are not providing anything. So in that case, we would have to provide min, and then we would also have to provide max. So yeah, so as you can see, using require, then using parameter list, using name parameters, all helps us to basically solve all these issues or errors that might would have occurred after we ran the program. But here, because of the syntax in that, because of null safety in that, we can solve all these issues at the compile time itself. Okay, so here, so if by chance if I had not provided anything and it compiled successfully, no, it would have been throwing error in the application, which would be a lot more hard to see, because it's hard to see what's actually happening in the app. So this was all about functions. Does anyone have like any kind of doubt, or you want to me to repeat any specific topics, guys?
Yeah, hello.
Yeah, hello.
Actually, what is the null input? Like how the input will be appearing if it has to be nullable?
Yeah, see yeah, okay. So now let us say that you're providing a text box for the user to like enter the name, right? So now they can enter the name as, let's say, uh, ABC, and then they can hit enter, and that value of ABC will be set to your variable. But now the thing is, the user may just press enter without doing anything, so the box will be empty. So in that case, a value of null can be stored in your string, right? So yeah, so if you had just put it over here as, let's say, string name, if I just put it like this, so if you had a function which would have assigned the name here, so you could have called this function and it would return the name of the person that he entered. Yeah, so if we had actually entered a valid string, then we would have stored string. But if we did not, right? Okay, so here basically yeah, like as you were asking, null, it's just it is just a representation, right? So if you look at some of the examples, so if you look at the symbol pi, like pi has no meaning, but we say that pi is equal to 3.1415 because we have said that pi is, pi basically represents that value. So where same thing also, we like null, like it can be 0 or it can be just like an empty string or no input at all, but we're saying that null will happen for these kind of statements, for when the input is actually empty. So those things, so we are basically representing all those cases using the value null. Okay, so you can uh, think of like uh, okay, so how you have 0, 1, 2, 3. Null is like in any other value that you can store, but here we are saying that like as one represents an odd number, or it represents the first number in positive integers. Same way, null will represent some specific cases that we define. So it can be in the case of empty inputs, or it can be in the case of like something happened with your app and the user was not able to provide us input. So in that case, we can say that the name that he could not enter is null. Is that clear for you, or do you have to explain it again?
Yes, yes, it's clear. It's clear. Thank you.
Yeah, good. Anyone have any other doubts? Let's check the chat. Okay, that's cool. Okay, now let's move on to a bit more advanced topic, and this is actually the most important topic in Dart, because Dart is object-oriented programming, so you need to learn the concepts of classes. Okay, so now I was saying, right, that object-oriented programming is mainly about having a class which will store the features, attributes, functions of all the thing that we're trying to model, and then we can perform some operations on it. Okay, so now let us try to create a class. Now let us say that I want to model an animal, right? So what does animal do? So let's say I have an animal. Now to have a class called animal, first we need to use the keyword class. So class, I'll say animal, and then I can start the body of the class inside a pair of braces. Now, so if you have a pet, your pet will have a name. So same way, let's give it a name. Let's say string. It can be nullable name. Now, yeah. So this is basically done. Now, so these are the features of animal, right? So it can, let us say, it can have a number of legs, or something like, so it can have 4, or you can just have it nullable for now. And then what do they have? They can have a double, they can have their own weights and all that. So there are so many things that an animal can have. Now so these were the attributes of animal. Now let's move on to the functionalities of animals, right? So now one basic functionality is that they can, so if it's a dog, it can bark. If it's a cat, it can meow. So yeah, so it can basically speak on its own, right? So now let us say we want to create that functionality. So we just write a function. So we wrote this function, right? Like it's the same way, we just write it inside the body of a class. So I'm going to say void, let's call this function speak. Okay, so speak, and speak is going to just print, it's going to say hello, that's all. So now yeah, so as you can see, this is the functionality of this animal, right? So whenever the animal has to speak, it is going to use this function body and say print hello. Now we have done with what are the basics of a class or an object, right? So we created its attributes, we have created some functionalities it can have. Now let us say we want to create objects of these classes. So here this class is basically it's just a recipe, right? So it is just say that what you have to do, and what it has, and what it can do. But now you can't use this class directly. You need to make objects of these classes. So to make objects of these classes, you need to have a special function inside the class, and that function is known as a constructor. Okay. So a constructor does not begin with any type, so it doesn't have like void or int anything. It just starts with the name of the class. Here it's animal, so the name of the class will be animal. Okay, and it's just a function, right? So it will have a parameter list, and then it will have a body. So yeah, that's all. So this thing is known as a constructor. Now, let us say we want to make objects of these. So let's go down here. Let's start with classes now. So now I want to make an object of this class, right? So how will I make it? Now here, until now we're just using int, double, strings and all, right? So now we can use a special data type which we ourselves are defined, and that is known as animal. So now I can say animal, let's just call it small case animal equals. Now how do we have it? So now this is a variable of the type animal. Now to have it, so yeah, for this object to have an base and what do you can call it an instance of this class. So to have this instance, you have to call this function. Okay, so you have to call the constructor now. Okay, so you're done. So now you have created an instance of the type animal using the constructor, and you created an object animal. So now you can call the function speak. Right? So if I want to call speak from animal, all I have to do is just say animal, then dot. So here you can access all the member variables also. So you can say names, the number of legs. So you can access everything with the help of the dot operator. So you can just say animal dot speak. So when I do this, this function will be executed, and this will be printed. Now let us say that I want to make it a bit more fancy, right? So like along with hello, I want it to also say its name. Hello, my name is. Now here the name will be name, right? So how do we do that? Now here, since we are like, okay, so there are like a lot of ways to do that. So I can either say this. So here, this is a string, right? So I can append like the name string. So since it's nullable, I'll say it is not nullable and do this. So as you can here see, name itself, it's basically a string type, right? So I'm just taking a string and adding that to another string. So the effect is basically it's going to print hello, my name is, and then the name of the animal. Or what Dart provides a much more simpler way is it is known as string interpolation. So what do I do is I just use the dollar sign and then say name. Okay, so over here it is going to take this whole dollar sign name and then replace it with the actual string that we stored in name. Okay, so now we have the function that is going to print the value of its name. Now we can have it set here. We can say the name is, let's say, alpha or something. But now, so if I have like another object, if I make another object, animal two is also an animal. Then if I call animal2 dot speak also, it is going to say the same thing, right? It's going to say hello, my name is alpha. And so here we are basically using the same name for both the animals. So now we don't want to do that, right? So what we do is, now since the constructor itself is a function, right? So we can pass some parameters to it. So let us say we accept a string value name, and then like what we do is we start with a pair of colons, and then we say name, and then in brackets. Okay, so this might be a bit confusing, so let's say uh, yeah, let's call this pet name. So now I would write this as a syntax. Okay, sorry, yeah, or you could have just done this. Yeah, so now I can say name that we have over here, right? So this name, now we are assigning it to the value of pet name. So now what I can do is I can pass some names here. So I can say the name of the first one will be alpha, and then I can say the name of the second one will be beta, and so on. So now whenever I call these speak functions, here the name will be different according to the constructor that I had passed. So yeah, just you can see that this is very helpful, right? But again, we have written actually one line extra code over here, that name equals pet name. So and now that's because we don't really care like what's pet name, right? Like whatever it is, we're just like storing that value in name, and then like we are not using pet name again. So what we could do is we can just strip all this out. We don't want this type. So what we can say is just write this dot name. Okay. So here, like what I'm saying is the first parameter that will be provided, which is alpha here. Now that has to be stored in this, means now here this it's actually referencing the current object. So if I had call the constructor for animal 2, then this would be referring to animal 2. So here I'm saying this dot name, right? So this dot name would be the name for the object animal 2. So here, whatever name it would be providing, that would directly be stored into this name. So here we don't require the extra variable pet name and all, right? So now again, so we can also have it as a named parameter. Okay, so you can have it as name and then colon, and provide the name of the alpha, again name, again provide the name of the name of beta. So you can do this. So this is pretty cool, right? Now again, so if first thing was like not nullable, then again we would have to write here required over here, and it would work. Okay. So now this is the basics of classes. So this is how you write class, and this is how you make objects of these classes. Okay. Now let's go a bit more fancy. Now yeah, so now let us say that I want to make like another class called dog. Now a dog also will have a name. It will also have some number of legs. It will have a weight, and will also have a function to speak, right? So it can bark. So now I could just write class dog, and again write all these things again in that class body also. But what we can use over here is called inheritance. So what I say is I say class dog. Now, dog is basically a subtype of animal, right? So, for doing that, I'm going to use the keyword extends and then write animal. So here I'm saying that the class dog that I'm going to define will be it is basically going to extend the animal class which is already written. So over here it will already have these functionalities of, let's say, name and speak and all. So here as you can see, there's a syntax error, and that is because this dog extends animal, right? And here animals constructor requires a parameter. So if this parameter was not there, so yeah, so it will be fine, right? But since here we have a parameter, let's first write the constructor of the dog. So let's say dog, again a function and the function body. So now again let's do the same thing. Let us say it requires a it requires a string. Let's make it a name parameter, string name, and then now how do we pass it to animal? And that is really yeah, we put required. Okay, yeah, so and now we have the name of the string, right? So now how do we pass it to this class? We put a pair of colons, we say super, right? So super is basically the super class. So here a dog is a subclass or a child class, and animal would be a super class or a base class. So I'm going to say that super's constructor will require the parameter called name, and for this we have found the variable. So let's again name it as pet name to avoid confusion, and the value of pet name will have to be provided to the super, right? So it's easy, right? So you have to just take the value of the string and then pass it to the constructor. So if you had like some more things over here, you could have done the same. If it required also the number of flex weight and all, you could have just taken the values through doc constructor and then pass them through the base class using this super constructor over here. Now let's create an object. Let's say dog. So this will be an dog object. Now to provide it a pet name, let's call it Sunny. Okay, so we have created a object of type dog now. Now, yeah, so as you can see here, we have just written the constructor, right? But the thing is, since dog extends animal, this is perfectly valid. I can say dog dot name. So as you can see, name is not here, but it is inside the animal class, right? So, so the subclasses can also access the fields which are inside the base class also. So you can just say dog dot speak also. So again, so it's gonna say its name now. But now, like I was saying, dog specifically barks, right? So like it doesn't say its name. So now I want to have a separate statement for speak. So if it had a speak, I could say speak, and then for speaking, it should just bark, right? Yeah. But now, since so you can see that speak is also defined under dog and it's also defined under animal, right? So it's a bit of confusion. Like when we say dog dot speak, where should it go? Should it go to the dogs class or should it go to the base classes function? So for that, what we do is we use the annotation and we write at and then we write override. So here, what we're doing is we are saying that speak. So the speak function with the same type and same parameters, it's already present in the base class. But here, like what I'm saying is saying that I don't want the functionality of this, but I want to basically override the functionality of this function as this. So now when I call dog.speak, so it's going to come here and see that we have basically rewritten the functionality of speak function. So like instead of searching both this and this, it is straight away going to execute the like overridden function first. So when I do dog.speak, it is going to uh, print bark. Now, so now a base class can also have some of its function on its own. So you can say get number of legs. So this function is just going to return its number of legs. No, yeah. So over here we also can have the function which are not defined in base class, but these are separate. So you can again do here dog dot get number of legs. So this is perfectly valid. Now the yeah, so like right now dog is a subclass of animal, right? So what I can do is I can have a variable which let's say it's a dog animal. Now I can just set it equal to dog. Yeah, right. So here was the type of dog? It's a dog type. But here we are storing it as an animal. So here, like what is happening is since the dog, it's basically a subclass of animal. So so in that, like any subclass you have, those can be treated as the base class also. Yeah, over here it makes sense, right? Because a dog is a dog, but it's also uh, like at its basic it's also an animal, right? So a dog can be a dog or an animal, but you can't have each animal to be an animal and a dog also. So here so basically you can't have this, you can't have a dog and then you can't save it to a sheep. Okay, so that you can't do, but you can take the object dog and you can also treat it as an animal. But the thing is now so you can do the same functionalities, right? So you can just say dog animal, I can say speak and all. But the thing is I can also access name, but since here I cannot do this, I cannot say get number of legs. So here now here we had a dog and it did have this function, right? But here, since I'm treating dog as an animal, I can only call the functions which are specifically written in the animal class body. Okay, so now since get number of legs is not defined in animal, I cannot do this. Okay, so this is all. And one more thing in classes and like inheritance is the concept of abstract classes. Now it's really simple. So we just need to write the keyword abstract class. So now what abstract classes do is they don't write the like implementations themselves. So the speak function would be, yeah, so it would just be empty, right? So if we had some other method, it would be void, let's say run. That method also like would be empty. Now let's say that dog has to do this, right? So over here, when we're using abstract classes as the base type, we usually go with the keyword implements over here. So here I'm saying that the class dog is going to implement this function called a class called animal. Now, so as you can see here, there are few names. Okay, so you can just right now this is not required. We can just ignore it for now. Okay. Yeah. So over here we have one more small error, and it is saying that we have a missing implementation for the number of legs one. Okay, so you can just take this. Yeah. So now right now we had speak and run. Right now, since we had speak and run, we need to have the like implementations of both the functions in the doc class also. So I would again write override, and then I would write void run, and then I would do this. Okay, so now it's all fine. Yeah, these things are not much required. You can just leave them. Okay, so over here we have this thing. So over here I'm saying that the functions which are defined under animal, they just like interface. So they just say what has to be done, but they don't say what, like how those things have to be done. But when I write a class using implements, it is going to say that so these functions were already defined in animal, and I am going to say how these will be implemented. So speak is going to say bark, and run is going to say, let's say it's just going to say I ran. That's all. So these were all the things about classes and inheritance. So I can safely say that, so if you had no doubts in this, so you probably know a bit of Dart now. So you can implement your own programs. You can, if you know like any other programming language, you can implement those, some program that you had done in this Dart, and you can try them on your own. So now, until now, like whatever I taught, does anybody have any doubts? Hello? Is any is everyone present, or just away from the keyboard right now?
No doubts.
Okay, that's good. Thank you. Yeah, so let's go back now. Until now, whatever I taught was just about Dart. So let's now also quickly move on to Flutter now. Now, yeah. So for
Nirul,
yeah,
repeat abstract classes.
abstract classes. Okay, yeah, sure. Now, what are abstract classes? Like abstract classes only say the things that have to be implemented, right? So like for, let's say here we had animal. So here we're saying that the class animal has name, it has the number of legs, and has a weight, and also each animal can speak and it can run. But here we are not saying anything, right? We're not saying how the animal should run or how the animal should speak. We're just leaving those functions empty. So now this is basically an abstract class. So if you create, so if you create like object right now, this basically this is like not useful at all, right? Because here the functions are empty, and these variable, they don't have any meanings yet. So what we do is we create another class which is going to implement this. So here we had the function speak and run, right? So it's going to implement these functions, and it's going to say that, okay, so we had a function called speak in animal class. So now I'm going to say that this speak function has to print bark. So that is the implementation that the dog class is providing to the speak function. Same thing for a run also. It is going to override this run method, saying that when we call run, like you would have to print I ran. Okay, so if you had like another class, let's say if you had a class sheep, so that would also do the same thing. It would implement animal and everything. You would have the constructor and stuff, and then it would do at override, and then it would say void speak, right? So it was speak. It is going to print bleat now. Okay. So here now the sheep is implementing the speak function as a printing bar, but here dog is printing bar. Okay, so that's how you make abstract classes, and you make implementations of abstract classes. Is that fine, guys? Okay. Okay, very good. Okay. We are a bit slow, so let's quickly hop onto Flutter now. So I'm sure that I hope that most of you would have attended the first session that we had on Thursday or something. So over there, Flutter was already introduced to you guys, but even though I'm just going to brief over it very quickly. Now, Flutter is an open source framework to develop cross-platform applications. So it was developed by Google, and by open source I mean that the code that is for Flutter, it's already on GitHub. So if you know GitHub, you can just go and search Flutter, and you can see the whole source code over there. And the thing that is very good about Flutter is that like it is not just Google who takes care of the code; it is all the community members also who take care of it. And because of Flutter, we can develop apps, with much ease. So if you try to make an app in Java, you would require very little effort to make the same app in Flutter. And also, if you make an app in Java, it's mostly for Android. But if you make an app in Flutter, you can have it on any platform you want, and you don't even have to write it once again for each platform. So we just write it once, you're done, right? So that is why we also use Flutter. We Iris use Flutter, so that so that we don't have to work separately on Android, iOS, or if you plan to make a release for Mac OS and desktop, we don't have to repeat the code again, right? So now first let's go how we Flutter. Now on Flutter, there's a terminology called widgets. Okay. Now what are widgets? So if you go to your phone and to see your home screen, you can see a lot of widgets, right? So if you have the search bar widget, then you have the calendar, which shows the time and the date, and so those things are examples of widgets. Now, when you come to Flutter, what are widgets? Widgets are basically the building blocks of Flutter, right? So like anything you want to show on the screen, that has to be a widget in the code. So this widget will basically hold the functionality, the data that you will have to require to show something on the screen in the widget. So now, so if you want to show, let's say, so if you want to show a text, so text saying Flutter, so you can do that using the widget text. Now that widget will hold the string that you want to display. So here it should be Flutter, and then you can also say what will be the font color, font size. So all these details that you will have to require to show that string on the screen, right? So all these things, all the position on the screen, its size and all, everything will be held together in the code through the help of widgets. Now, right now, we just saw how we wrote classes and all, right, in that. So now we, like implement widgets using classes, objects, and inheritance. So here, what we make use of is we make a few widgets and we basically uh, relate them to each other through parent and child relationships. Okay, so I'm just going to show a very basic example. So here, this is a weather app. Okay, so now the first widget that you can see, so the one that I've marked in red, and that widget is known as a scaffold widget. Okay, so a scaffold widget basically provides a paper for you to show all your widgets over there. Now the one in white, that is known as an app bar widget. So does the app bar. So if you go to any of the apps like WhatsApp or something, the top bar where you see it's written WhatsApp, search bar, everything is there. That is known as the app bar. Now, after those things, you have some other examples. So here, this one is known as a column widget. Now, why is it called a column widget? That's because we have various text. We have New York, then rain, then the temperature, then this icon and all. So we are showing these different widgets inside a column over here. So that's why to group all these widgets into a single one, we wrap all these widgets into a column widget. So here, as you can see, this small box is the example of a text widget. It has some text that is showing in some color, which I can customize. Now here we have a list view, right? So now, what's a list view? So if we want to show like not just one thing, like you want to show like a lot of uh, widgets which will have a slightly different information on them. So for that, you use a list view. So we are showing a list of these things, right? We are showing list of the weathers in each city. So here, this each box is known as a card. So you can make them using a card widget. Each card again contains a column, and each column contains text. So these things. Yeah. So I was saying about the child parent relationship, right? So over here we can say that a list view is the child. Sorry, list view is the parent of card widget, and each card has a column, and each column has the text, right? So here I can say that the text is a child of column is a child of card is a child of list view. So here, and like why we do this, it's also like much like it's intuitive for us to understand, right? So we're saying that text will be inside the column will be inside a card will be inside a list view, and this list view will be inside the body of the scaffold. So we can, it's much easier to understand and write the code. So that's why we have this parent child relationship. Now, after widgets, the next most important thing in Flutter is called state. Now, state, like it's again, so as I said, widget is going to represent the thing that we're going to show on the screen. State also represents something else. Now, a state in Flutter will represent any kind of data you want, like let's say a text or the size, like it can be anything. So state basically represents the data of the widget, right? So it is not going to say that how the widget itself will look when you show it on the screen, but it has the data that it will be showing through the widget. So if you have a text widget, then the data that can be shown in the text widget will be its a string. So the string is a state of the text, and then the color of the text also can be the state of the text, and so on. So if I have a widget, now the widget state is there. That is state, or the data will be stored in state object. So here we are basically saying that the data that it has to be separated from how it will actually look on the screen, right? So that's why we are going to separate the data and the uh, like appearance part of it. So here I have written simple equation that you can remember. So the UI, that is the things that you're going to show on the screen, will be a function, and these functions are how you say your widgets have to be built, and these are a function of the state, that is the data in each of the widget. So does like anybody have any doubt with state of widgets until now? Okay, cool. Let's move on. Now, so I said state and widgets, right? So now let's combine them both. And so in Flutter, widgets are broadly divided into just two categories. One is stateless and the other is stateful. Now, what's a stateless? Just like as its name suggests, a stateless widget does so its state never changes, right? So if you have a text and you say that it has to display the text Flutter, so that widget won't change anytime because it knows that it has to show Flutter, so it's always going to have the data Flutter inside it, and its UI or the data won't change. So yeah, so some examples are text and icon. Yeah, so when icon also, right? So if you have a photo as an icon, you don't have to change it again and again. So it's just a single static photo you have. Next, you come to stateful widgets. Now, stateful widgets are those widgets whose states can be changed. So because of that, they're also dynamic in nature. So if there's any event that you have specified, so like if a box is tapped, or here there's a slider, right? So if you slide the slider, the text which is above the thing also changes, and also changes from continuous to discrete and all, right? So here these are all stateful widgets where its data can change, and because its data is changing, the thing that you show on the screen also has to change. So that's why these widgets are dynamic in nature. Okay, now how do we implement stateless and stateful widgets in Flutter? Now, stateless widgets are really simple. Stateless widgets just inherit from the stateless widget class. So, stateless widget, it's like already a class that is defined for you in Flutter. So, if you want to write any other stateless widgets, you have to just inherit from the stateless widget class, and then you can write the same any code that you want. Now, on the other hand, how stateful, which okay, this is not stateless. I'm sorry. Now, how stateful widgets will be implemented is they have to be subclasses of a stateful widget and a state widget also. So here it is not the child of just one class. Now, a stateful widget, again like stateless widget, is also defined in Flutter, and you can just directly inherit from it and write your code. Now, this your widget also has to inherit from the state widget. And now state widget, yeah, so basically here whatever data you want to store will be inside the state widget. So, and whatever you want to show on the screen will be in the stateful widget. So you're again separating the state from the UI. And now yeah, so now so for stateful widgets, since you can change the state, now like you need to also change the corresponding UI on the screen, right? So for that, what you do is you use a function known as a set state. So it's a function, and for the function, it requires like another function to be provided as a parameter. So whenever you call a set state, that particular UI will be built again. And since you have changed the data, that change in data will also be reflected in the UI, in the final UI. Okay. So this might have been a bit boring. So let's just directly like implement it. So now first let's write a stateless widget. Okay, so now here I've written stateless widget. So you can yeah. So for okay, so if I had not imported any of these, I can also yeah. So you can right now these are errors because I need to import a package called materials materials dot from Flutter. So if I do this, there's no error. Okay. Yeah. So now yeah. So now here so this my widget is my status widget that I want to implement, and it is going to extend the stateless widget. So I said that it has to inherit from status widget, so it is going to extend stateless widget. And over here it has a it also has a constructor. Now it has the keyword const in front of it, which means that the constructor is constant, but like you don't have to worry too much about it. Even if const wasn't there, it's going to work just fine. And here you're passing a key again. Now keys and keys are a bit more advanced, so let's not talk about them. So let's just say that the parameters accepted by this widget will be a key. Now here now these stateless widget so this method called build. Now this is again a function, and this function is inside the stateless widget, right? So if you want to have our own implementation of this, we will have to use the annotation at override. So we're going to write at override and then say that this function will be doing how I want it to. So here we write the return type of the function as widget. So again, widget is like any other data type in Flutter. So here we have the data type widget built, and for its parameter, it is going to accept a context. Now, again, a context is a bit high level topic in Flutter, but basically what a context specifies is, it just says that this widget was built at this particular instance, right? So at this in this particular situation. So for this, you can use this particular context, or if you build the uh, widget again after some time, so that time the situation might have changed, right? So that time you would have like another context. So you're basically using the context to navigate like where the widget is. Yeah, so I showed a widget tree, right? So over there, with the help of context, you can actually find where this widget is through the help of a context. Now, after this, we have the body of the build method. So over here, again, we need to uh, return a widget, right? So now Flutter on its own gives you a lot of widgets on its own. So yeah, some examples I said with what I said it text, right? So I can have a text, and the data, let's say it's gonna hold the data Flutter. Okay. So yeah, so as you can see from this build method, I'm going to call this text Flutter. So whenever this whole widget will be built, that time this text will be shown on the screen. Now again, you can make your own functions also. So let us say I make a function that is specifically going to return a text widget. Let's say I call it text widget, and then I just do this, and here I say return text Flutter. Okay, so now I can replace this whole thing with just this widget. You can say text widget. Okay, so this is also fine. You can do this. So, yeah, so you can see stateless widgets are like they're very simple, right? And if you want to learn a bit more, you can just if you hover over here, you can see a link to a YouTube video, which yeah. So this is by the official developers of Flutter. If you have any doubts, you can just watch the video, and I'm sure that you're gonna understand it much more better than uh, what I thought. So this was stateless. Let's quickly move on to now stateful. Now stateful is a bit more complex. Uh, it's a bit more complex. So as you can see here, we have one class and we have also another class. So just let's understand it like step by step. So again here, my widget 2 will be my stateful widget that I want to implement, and it's going to again extend from the stateful widget now instead, right? So instead of stateless, you're going to use stateful, and again it has its own constructor. It's a constant, so it doesn't matter much, and again it takes a key. Now this stateful widget also has a function called as create state, which is going to return a type of state. Now here we're using state of my widget 2. So these are basically known as generics, but like like you don't have to completely know this stuff. You can just leave it. So all that you have to know is that this function is going to return a state object. Now over here, yeah. So they use the fatter operator. So I hope that you remember why this is used. So from this function, we are basically overriding it to say that whenever this function is called, this class has to be returned. Sorry, this instance of this class, which is my widget 2 state, has to be returned. Now, this is all about the stateful part. Now, let's come to the state, right? So, yeah, like I said, a stateful widget has to implement the stateful widget by Flutter, and also it has to extend a state also, right? So here we have to write this. So whatever we return, that has to be made as another class. It has to extend again a state, and then again, so it has to extend a state of my widget 2 because we're making it for this class. Now in here, over here, like you saw, stateless widget had a override called build, right? But for stateful widgets, this build method won't be inside the stateful implementation, but it will be inside the state implementation. Why? Because state can change. So like whenever the state changes, you can just call this method to build it. Okay.
So this will be covered in counter app. So we can continue in the next session.
Okay, fine. And that's all. And then you want to override it basically and say that you want to build this one. So let's do the same thing. Let's copy this implementation in here. Yeah, so again, this method also is going to return a text widget, and that will return a text flutter. Now so now since this is stateful widget, right? So I can have a string which was initially to Flutter, and instead of saying it has to display Flutter, I'm just saying that it has to show this string str, right? Now there may be sometimes when this string may change. Okay, so change string function might be called, like uh, how it's called or like when it might be called, we don't know that. But here change string might be called. So here what we do is, if the string was already equal to Flutter, then we are going to set Flutter as the string as dart. Else if the string is now dart, we're gonna just reverse the string back to Flutter. Okay, so now so here whenever the change string function will be called, this string will be, if it's Flutter, it will be changed to dart, and it's dart, it will be changed to Flutter. So here, yeah, we can say that, yeah, so we are done. So we have changed the state of this stateful widget, which is my widget 2. So when I change the state, its UI like will also be changed, right? So here I'm saying that it has to only show the str. So I'm not saying it has to show Flutter. I'm just saying whatever the value stored in str, it has to be stored in Flutter. But the thing is, we are missing one step, and that is we have to call set state. So until and unless you call set state, whatever changes you do will be stored in the variable. That's correct, but that change won't be reflected on the screen. Okay. So if a string was Flutter, so after something happens, the it will still show Flutter itself, because we did not call set state. So now after calling set state, now everything will work as we wanted. So after we call set state, it is going to build this again. So in that case, it will see that the value of str will now be Flutter. So it's going to change, it will now be dart, so it will show dart on the screen. Okay, now yeah, so as you can see, this set state function, it's a bit weird, right? So it has a lot of braces and all. So we can simplify it a bit. You can start step by step. So now what set state? It's a function, so it has to have its a parameter brackets. Now the parameters, what it has to have is a it's like another function. So basically, so how do you write functions? You just write, you give it a parameter list, and then you give the body of the function. That's all. Okay, so here, like, you don't have to write the return type, or you don't have to give the function name. You can just start with the parenthesis and then the body of the function. And like, why do you require a body here? So now, as you can see, I've changed the value of string first and then called set state. But what I can also do is I can also remove this. I can just directly call set state, but I can put that body in the function body of set state. So I can do this. So if I do this also, it won't matter. The string will still be changed and the UI will still be updated. But one wrong thing that you can do is that is calling set state first and then changing. So here, when you call set state, yeah, so the state will be built. But since you're not changing the string, that string, like, the UI won't be updated, and you will still be showing the same string. After that, you are updating str, like, that will make any sense, because the UI has already been updated. So this is wrong. So don't do this. You can do either keep it inside the body of set state, or you can keep it before you're calling the set state function. Okay. So now, yeah, this was all it for this session. We covered all the fundamentals of Dart. Now, how we declare variables, then functions, then how we use classes and inheritance, and then we came to Flutter, where we showed how we write widgets, what are stateless and stateful widgets. Now we did run a little short turn time, so I could not show how stateless and stateful widgets work actually on the app. So this topic, will be covered in the next session also, where we actually show you how how an app works, what is the how we structure an app, how how we can make changes to the app, how we implement stateless and stateful widgets. So for this session, I would say this is it. Does anybody have like, if you have any doubt, not just related to what I taught today, anything about Flutter in general or about this boot camp, you are free to speak now. You guys have no doubts at all.
Hello, sir. Anirudh, sir. Good evening.
Yeah, hi, sir.
So, yeah, I wanted to know that part I understood well. After that, it was too quick for me. Can I continue with the bootcamp next session?
Yeah. See, the thing is, now actually, I was not supposed to cover this much of Flutter also in this session. That's because in the next session we'll be explaining, a bit same thing. We'll start from how we declare stateless or stateful again. So you don't have to worry. Like, if you just understood the basics of that, and then if you understood like border widgets and those stuff, like you're fine. Like, we'll also be providing the link to the recording of this session. We'll also give you some resources, some playlists you can watch. Yeah, so the next session will be anyway after 1 week. So you can practice a bit, you can write your own code. So you don't have to worry about not attending the next session at all.
Thank you, sir.
Yeah. And by the way, guys, the guy who just spoke is the current app team lead of Iris, who's Rashmit S. He's a fourth year. If you have any doubts, you can ask me or him also. Speak up freely.
Yeah, just to add on what he was saying, most of the sessions are not like prerequisites. Okay, mostly first 10 minutes we'll cover what happened in the previous session, and only then we move on. And as you said, in this session there are few parts that are covered which were not supposed to be covered. I mean, it just it took the speaker away on his flow. Like stateless stateful widget, I understand that it's a lot for you guys to take in now, but just understand, just keep in mind that if dart fundamentals, if you are understood that better, that is more than enough from what you can gain from this session. So don't be disheartened if you did not understand the second part, that is a Flutter fundamentals. That's not needed also as a prerequisite for next session. So keep attending sessions, we will make it easy for you to learn Flutter. Any doubts? Yeah, please ask. Only if you ask, we'll know that you guys are attending sessions and actually listening. Otherwise, yeah, as said in the first meeting, based on responses and attendance only, the sessions will be taken up. So if you don't respond well enough, then probably we'll move to what do you say, recorded sessions also. And I also wanted to know why less attendance today. Is there some exams or what is it? 5 o'clock is too early for you guys, or what? Why is it the way it is today? Someone speak up, no? Otherwise, I'll start picking. I can't see all the participants. I'll just call Rohit. Okay, Sonal, Shreya, bye.
Yes.
Yeah, what happened today? Like, why is the attendance low today? Is there any quiz or something for certain batch?
As far as first years are concerned, I think the quizzes are as for like maybe like we have different cycles, so maybe they're preparing for a quiz tomorrow, or maybe it's a Sunday, so they might be off.
Okay. How did you find the session? Too much?
And no, it was okay enough. Like I understood the most part of Dart, and Flutter is also okay.
So I can ask you questions now. Okay, cool. Anybody, please ask questions. I'll just mute myself. Let Anirudh take.
Flutter part was confusing. Yeah, it's like we're just saying, right? So Flutter was not supposed to be covered in that much detail. So it was confusing also. Yeah, even I understand. Like when I attended the boot camp, when we had the sessions, like right now we are having around 6 to 7 sessions for you guys. So it's a lot spread out. Back when we had the boot camp, we just had like hardly 4 sessions. So like everything was crammed up in one video. So like I understand how hard is it to understand Flutter on the just on the first session itself. So it's fine. Like you guys have like another week coming up. We'll be sharing the slides also. You can reread them. We'll be sharing resources. And yeah, like if you have any doubts, you can just ask any of us. Like we are free on Discord or anything. Yeah, so don't feel a bit demotivated that like you don't understand Flutter or anything. In the next session also, next session will be taken by someone who's going to explain much more better than me. So you can guys can chill. He will again say how do you understand Flutter and from the basics. This container is just like a placeholder. Yeah, see, uh, uh, Nandan, containers again just like a text widget or like any other widget. Okay. Now, container is basically the standard widget that we use. So like if we don't want to show anything, we just say container. So it's not exactly a placeholder. Like we are still going to say that this part will be a container, so it can contain some child. So the if you see the widget, the container has child. It has decorations and stuff. It is not exactly a placeholder. But if you don't want to show anything, if you don't want to return anything, you can use container as a placeholder. But you can also use like any other widget also as placeholders in few situations. Next out. Yeah, you will be getting the session. Don't worry. Uh, okay.
So guys,
Regarding, yeah,
this week there will be an assignment which will be shared very soon.
yeah.
It's an MCQ assignment.
Yeah, so the thing is, like we're not giving you assignments so that we can see, how much well versed you are in Flutter. We're just going to give assignments so that you can have enough practice. You can like understand what we thought. So if you think that you did not understand completely, you will know that okay, you did not get this part. So you can ask us, and we'll again teach you. So, and like if you didn't understand a bit also, we can have like any other doubt solving sessions also, like one-on-one is also fine. So yeah, these assignments are only for for self evaluations. Like we will be seeing how like who are all attending the meets, or who are attempting the assignments, and what's their progress. But it is not like a academic evaluation that we'll be doing. So you don't have to be like, okay, so if you don't understand anything, like you're not going to write the assignment. You can write the assignment like after the once you submit your assignment also, you will still have your feedback, you'll still have the questions. You can keep searching those questions, and you can understand about Flutter and Dart a bit more and more each week. Okay, yeah, we will be providing as much of materials as we can, so don't worry about it at all. And if you feel that the one that we are giving you are not enough, you can ask for more. Like there is no limit to what we can teach or what we can show you guys to. We are really, we are as much enthusiastic as to teach as you guys are to learn. So yeah, you don't need to worry about that at all. Any other questions, or if you have any suggestions about the way we are doing it, or about the timings or the communications? So anyone has any suggestions or any feedbacks?
Also, Anirudh,
Yeah.
make sure a feedback form is shared after the session. And guys, please fill in your feedback there. Like we'll be asking about the duration and the time when we have to do it, and whether it was quick, whether it was fast, and all those stuff. So please do fill in your opinion so that we can improve on upcoming sessions. Yeah. And yeah, I'll leave now, Anirudh. It was a good session. Take care. Bye.
Thank you. Bye. Yeah, so if no one has any doubts, or if no one wants to say anything, you can also speak about the experience in a college or anything. Thank you, Srihari. Okay, see guys, like you guys have to speak up. Like I understand right now, you might be a bit shy to speak or to open up. Like, as a first year, I do understand that. Uh, but again, the thing is, like after come to college here, academics actually becomes secondary. Your primary should be meeting as many people as you can, speaking to as many people, seniors or your batchmates, professors, everyone in the campus. So yeah, I would just suggest that you guys interact a bit more. Yeah, uh, that's all. Okay, I'll stop the recording. And if you guys